I'd like to go through an example with you of a concentration type problem. And here's our example. We're going to start with a solid solute here. So for a mixture of 22 grams of phenol, and I've written here solid, and 160 grams of acetic acid, calculate the following concentrations. And here we're also given the density of acetic acid. Since the phenol is a solid, we're not given a density for that. Alright, so first of all we're going to find the percent weight of phenol, or the percent mass of phenol if you like. And it's always about this percentage of the solute. Now we know that the solute is going to be phenol because it's a solid and the acetic acid is a liquid. Also it's pretty clear there's far more acetic acid than there is phenol in this particular solution. And since the concentration is always about the concentration of the solute, we know we're after the concentration of phenol. And the percent of solute is going to be the mass of solute divided by the mass of solute plus the mass of solvent multiplied by 100%. The mass of solute is going to be 22 grams, so 22 grams of phenol is what I've got here, divided by 22 grams of phenol plus 160 grams of acetic acid. Taking significant figures into account, in fact we've got 2 here and this would end up being 3, we're going to end up with 2 as our percentage. So this solution will be 12% phenol. So remember that if we're after a concentration, it's always about solute in the solvent or the solution. Molarity is going to be the moles of solute divided by the liters of solution. But first of all, we need to find out the moles of phenol, because we know that phenol is the solute that we're talking about. So it's 22 grams times 1 mole over 94.00 grams. And I get the 94.00 grams by looking at the molecular formula, C6H6O, then adding up the atomic weights of these as they appear on the periodic chart to give the molecular weight of phenol. Alright, so that's how I get the moles, and that came out to 0.23 moles. Again, we're looking at significant figures here, 2 sig figs and 2 sig figs. Now we're looking at liters of solution. Since phenol is a solid, it is not going to appreciably add to the particular volume of the solution. Solids are very low volume, they're very dense, and we tend not to consider them when we talk about solution volume. So all we're really interested in then is the liters of solution, which is going to be the liters of acetic acid. Now in the problem we were given grams of acetic acid, but we were also given the volume of acetic acid as well. Sorry, the density of acetic acid as well, and that will give us the volume. So what we can do is we can take the mass and multiply it by 1 mil over 0.800 grams. I just want to point something out here. In the problem, we were told we had 160 grams of acetic acid and that the density was 0.800 grams per mil. And what that means is that we can use this to figure out a volume, or we could use it to figure out a mass if we had a volume. Now we know that density is going to be considered to be mass divided by volume, but volume is also considered to be mass divided by density, or if you'd like, mass times 1 over density. Now 1 over density in this instance would be mils divided by grams. So you can see the mass and the grams will end up cancelling, leaving us with mils as our answer. So we're looking at the inverse of density in order to get what we need. Alright, so let's go back to the problem. You can see that illustrated. So what we've done here is we've got 160 grams and it's times 1 mil over 0.800 grams because the density was 0.800 grams per 1 mil. We have to arrange it this way so the grams cancel, we end up getting mils, which we can convert to liters. You've got to remember that molarity is moles of solute per liters of solution, which is why I had to do a conversion here to get it into liters, times 1 liter over 1,000 mils. Looking at significant figures, we've got 3 sig figs here and 3 sig figs in our answer, 0.200 liters. To get the molarity now, it's 0.23 moles divided by 0.200 litres to give us 1.2 moles per litre, or if you'd like, big M. Molality is the moles of solute over the kilogram of solvent. See, that's the difference between molarity and molality. Molarity is litres of solution, that's the entire solution, while molality is kilograms of solvent, so we're just considering the solvent here. We're already given the mass of acetic acid in grams, so now it's a simple matter to convert that into kilograms, and that's just times 1 kilogram over 1,000 grams. So we've got 0.160 kilograms, and that will be the kilograms of solvent. In no cases of anything we do will molality ever be concerned with the amount of solute we have when we're talking about the quantity that's on the bottom of molality. It's always just about the solvent, which is kilograms of solvent here. So based on the number of moles we calculated earlier, it's 0.23 moles divided by 0.160 kilograms. Our answer comes out to 1.4 little m, if you like. That's the unit for molality, or moles per kilogram if you want to. So little m for molality, big M for molarity. Now I want to point out here that the molarity is 1.2 molar and the molality is 1.4 molal. That's the language we use when we discuss that. And the other thing I want to point out is that molarity and molality are not the same value. They will be the same value if the density of this solvent is 1 gram per mil, as it is with water. But with acetic acid here, we've got 0.800 grams per mil, so we're not really talking about that. Alright, so that's why we're going to end up with different values for molarity and molality in this instance. Now, mole fraction is defined as being the mole of solute, and if we're looking at the mole fraction of phenol, it's going to be the mole of solute divided by the sum of the moles of the solute and solvent. So the moles of phenol over the moles of phenol plus the moles of acetic acid. Now it's not multiplied by 100%. It's kind of similar to percent mass, but it's not percent mass because we're not looking at a mole percent, we're just looking at a mole fraction. And you'll see when we do this, we'd have to calculate the number of moles of acetic acid, which would be based on the 160 grams. And we've also got the molecular formula, so we can figure out the molecular weight of that as well. And it came out to 2.67 moles of acetic acid. So the mole fraction of phenol is expressed using this Greek letter chi. So chi phenol equals 0.23 moles over 0.23 moles plus 2.67, which comes out to 0.079. Now, number of significant figures, we've got 2 sig figs here. We would have 3 sig figs on the bottom once we did this addition, because that would give you 2 decimal places, which would end up being 3 significant figures. So it'd be 2 sig figs over 3 sig figs, which comes out to 2 sig figs, so it's 0.079. To get the acetic acid, we do the 2.67 moles over 0.23 moles plus 2.67 moles, and that's going to give 0.921 as the mole fraction. Now, the mole fraction has no units because it was moles over moles, so everything cancels, and we end up with what is called a dimensionless quantity. The other thing you'll notice is that if you add these two together, they're going to come out to be exactly 1. And that's always the case with mole fractions. All mole fractions of all substances in a solution will end up adding up to 1. Which brings me to the point that you can also calculate the mole fraction of acetic acid by subtracting the 0.079 from 1. And I've done that over here. So the mole fraction of acetic acid can also be measured by 1 minus the mole fraction of phenol, 1 minus 0.079, which is 0.921. I want to point out that because this is 3 decimal places and we're doing addition subtraction, we're looking at 3 decimal places in our answer. The 1 doesn't figure into the significant figures. It's going to be a counting number, which is how we can get the mole fraction of acetic acid that way as well.